Lesson 13.6 is found on page 537 of your big book. Apply measures of center and variability. The essential question, what do measures of center and variability indicate about a data set? All right, so let's find out. Julia is collecting data on her favorite sports teams for a report. The table shows the median and the interquartile range of the heights of the players on her favorite baseball and basketball team. Baseball, basketball. Okay. How do the heights of the two teams compare? Well, generally speaking, basketball players are going to be a little taller, and our data indicates that as well. Okay. Compare the medians and the interquartile range of the two teams. All right, so the median, that's this data right here. The median of the basketball players' height is 8 inches greater than the median of the baseball players. Okay, so if you look here, these guys are 8 inches taller than these guys in general. 78 minus 70 gives me 8. Okay. Interquartile range. The interquartile range of the baseball team, notice these two numbers now, of the baseball team is greater than. 6 is greater than 4. Is greater than the interquartile, whoops, I'm not on the screen, is greater than the interquartile range of the basketball team. So the heights of the baseball players vary more than the heights of the basketball team. In other words, this interquartile data tells us that some of the baseball players are pretty tall and some of them not so tall, because height is not a big contributing factor in your success in playing baseball. Basketball, on the other hand, you have to be pretty tall to be terribly successful. Therefore, all of them are tall, so they're all within roughly a 4-inch interquartile range, meaning this is a very small number, so they're pretty close to the same height. This is a little bigger, so there's a bigger range between the heights of the baseball players. That's what that data tells us. All right, so the players on the basketball team are typically taller than the players on the baseball team. And the heights of the baseball team players vary more than those of the basketball team. So in other words, the players on the basketball team, they're all tall and they're all pretty close to the same height. The baseball players, there might be a shorter guy, there might be a taller guy. That's what this data tells us. There's more of a range, and they're shorter in the first place in general. They're not as tall as the basketball players because their median is only 70 inches, where the basketball players, their median is 78 inches. That tells us that they're all taller than generally speaking, than the basketball players. And there's a wider variety. These guys are more of the same in height. All right, so Julia randomly picks. What does she do here? She randomly picks one player from the basketball team and one player from the baseball team. So she just chooses one of these guys, one of these guys. Given data in the table, can you say that the basketball player will definitely be taller than the baseball player? For sure will the basketball player, if she just picks any player on the team. No. We don't know. she could have picked, it's possible that she'd picked a baseball player that was this tall, but because there's a shorter guy, their median number was shorter. But it's possible she got a baseball player who was taller than a basketball player, because the baseball team is a variety of heights. The basketball team is less of a variety. So no, not definitely be taller. So how do we say this? The median height of the basketball player is greater than the height of the median of the baseball players. Okay, so even though the median of basketball, b-ball, well, that doesn't work with this case, does it? Because baseball and b-ball, or basketball, they both are b-ball. Okay, basketball is taller. She may have, whoops, I'm getting ahead of myself, have chosen a baseball player who is taller than the basketball player she chose. Okay. It is highly likely, though, that the baseball player will be shorter than the basketball player. But she could have just picked the one random guy, or one of the two random guys who are taller than the basketball players. We don't know. It's not likely, though, because more baseball players are shorter than the basketball players. All right. Kamira and Joey sold t-shirts during lunch to raise money for a charity. The table shows the number of t-shirts each student sold. Here are their t-shirts. Each student sold each day for 2 weeks. Find the mean and range of each data set. Use these measures to compare the data. So here's Kamira. All right, to find our mean, we have to add all this up and divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're dividing by 10. That was nice of them. Okay, and we go 5, 1, 2, 1, 3, 3, 1, 4, 5, 5. All right, 5, 6, 7, 8, 9, 12, 15, 16, 20, 25, 30. That was nice and even of them. Love it when they do that. 30 divided by 10 is 3. So our mean for Kamira equals 3. All right, now let's figure out Joey's. We use this data set. 1, 2, 3, 4, 5, 7, 8, 9, 10 also. Although, interestingly, look at this one day. He had a killer selling day, one of the days. Most of them were kind of normal-ish. 2 days, maybe he was sick on those days or something, but he didn't have a lot of luck on 2 of them. But this one, he really sold a bunch. All right, so we have 0, 1, 13, 2, 1, 3, 4, 4. What did I do? 2, 1. Oops, I missed a 2. Okay. 2, 1, 2, 13, 2, 1, 3, 4, 4, 0. All right, so we've got 1, 3, 16, 18, 19, 22, 26, and once again 30. It's interesting. All right, so Joey's mean is also 3. They both have a mean of 3. Okay, so now we're going to find the range. Kamira's range is tighter than Joey's because he's got that outlier 13. So Kamira is, her highest number is 5 and her lowest number is 1. So Kamira's range is 5 and 1, so the range is 4. So she was within 4 t-shirts throughout the whole week on each selling day. Joey, on the other hand, was 13 and 0. He had wildly different days. So his range is 13. All right, so the mean of Joey's sales is the same as the mean of Kamira's sales. They're both 3. The range of Joey's sales is greater than the range of Kamira's sales. So the typical number of shirts Joey sold each day was the same. The typical number, the average number, was the same. As the typical number of shirts that Kamira sold. However, since the range of Joey's data was greater than Kamira's, the number of shirts Joey sold varied more, a lot more, from day to day than the number of shirts Kamira sold. So which measure of center would better describe Joey's data set? Of the two that we used, so there's okay, so they're not looking for just the two that we used. So there's mean, median, mode, and range. Okay, so we have mean, and they have the same there. Range, Joey's was wildly different. So this doesn't do us much good. This was so wildly different, it really doesn't give us a good picture. At 13 doesn't give us a good picture of Joey's overall selling, because this was just one crazy fluke of a day, and these were, who knows, he might have even been absent on those days. So the range isn't really a good measure of center either. So then we've also got median and mode. Okay, so the median of Joey's data set. Let's see. So we've got to put them in order. 0, 0, 1, 1, 2, 2, 3, 4, and 13. All right. The median is 2. All right, so our median equals 2, and our mode is 0, 1, and 2. 0, 1, and 2. So I would say that the best measure of center would be actually the median, this 2, because it shows up again in the mode. And basically it says he sold roughly 2 shirts a day, or 3 shirts a day. You could argue the mean also under those circumstances, that he sold about 3 shirts a day. So you could say, let's say you did go with the median. So the median is 2, which is close to the number of t-shirts Joey sold on every day except one day, the one where he sold 13 shirts. Okay, so look at this so that it makes sense. 2 is really close to all of his numbers except this one. It's pretty much right dead in the middle of 0 and 4. If we got rid of this outlier number, 2 would be dead in the middle. So 2 is actually a really good measure of center. All right, in this case. All right. Zoe collected data on the number of points her favorite basketball player scored on several games. Use the information in the table to compare the data. All right, so here's our player 1, had a mean of 24 and an interquartile range of 8. Player 2, 33 and 16. Okay. All right, so the mean of player 1's points is 24, right? And player 2. All right, so this is less than the mean of player 2 points. The interquartile range of player 1 is also less than the interquartile range. They're both less than. So player 2 typically scores, player 2, this guy or girl, typically scores more points than player 1. But players 2 scores typically vary more. So this person generally scores more, but the scores also vary more. So some days this player's getting 50, on other days this player's getting 10. This player is more consistent. They're getting, more like 20 to 30 points every game. That's what this interquartile range is telling us, that they're a consistent scorer. This one is a little, they have really good days and not so good days. This one's just consistent and solid. All right. Mark collected data on the weights of puppies at 2 animal shelters. Find the median and the range of each data set and use these measures to compare the data. All right, so we've got to find the median of shelter A, median of shelter B. So that's 7 plus 10 plus 5. Make that look like a 5, plus 12 plus 15 plus 7 plus 7, all over 1, 2, 3, 4, 5, 6, 7. So it's 17, 22, 34, 49. 49 plus 7 would be 56. Plus 7 more would be 63. So we have 63 divided by 7, which is 9. So the mean is 9. Okay, let's figure out the mean for shelter B. We've got 4 plus 11 plus 5 plus 11 plus 15 plus 5 plus 13. All over 1, 2, 3, 4, 5, 6, 7 again. All right, so that's 15, 20, 31, 46, 51. Am I right? Okay, let's try that again. Sorry. Okay, 15, 20, 31, 46, 51. So that would be 64. They gave us such a nice even number before. I thought 9 point, let's see, what would that be? 9.1, on and on and on. 7 goes into 64 9 times. 10 is 1, 7, 3. 7 goes into 3 4 times with a 2 left over. This is complicated. Okay. We're only going to take it out to the hundreds place. All right. So this mean is 9.14. All right. Find the median and the range. Okay, so our range here, our mean is 9 and our range is 15 and 7. So this range is 8. This range is 15 and 4. So this range is 11. Okay. So, for shelter, find the median. Oh, for heaven's sakes, and the range. I found the mean. All right, well, let's find the median. Here we go. 5, 7, 7, 7. 10, 12, and 15. Okay, so our mean would be then 7. All right, so this is our median, median. 4, oops, sorry, that's our median. For shelter A. For shelter B, the median, where am I going to do it? We'll do it right here. Okay, it's 4, 5, another 5, 11, 11, 13, 15. Okay, so working our way in. Okay, so the median for B is 11. And use these measures to compare the data. All right, so shelter A. Median 7, range 8. Those are very similar numbers, aren't they? Shelter B, median 11, range 11. Oh, even more similar numbers. Okay. So, they both have a very similar variation in their data set. The typical weight of a puppy in shelter A, in shelter A is less than the weight of a typical puppy in shelter B, right? So they're not, their median and their range data is very similar to within the shelter. So the typical weight of a puppy in shelter B is greater than a puppy in shelter A. Meaning, there we go, A. This shelter, for whatever reason, just gets smaller puppies in general. This one gets a little bigger puppies in general. There's a couple of them that are different, but these overall, they end up with smaller puppies. Don't know why, but that's what the data tells us. Okay, good luck.